Nice to see you all, and thank you for the opportunity to speak here about CCS. First of all, apologies for not being present in Frankfurt. That was the original plan, but thanks to a unplanned COVID last week, I am therefore limited to do this presentation virtually. But still, and nonetheless, really good to meet you all, and looking forward to present you a bit more information about CCUS and what that can enable for our climate ambitions. So I represent the company Aker Carbon Capture. We are a pure play market leading carbon capture technology provider. And I'm going to tell you a bit more about what we do and how we do it later in this presentation. But first and foremost, I will take you through a bit of an intro to the CCUS, and that stands for Carbon Capture, Utilization and Storage, and the market around that. So in the next slide, you'll see a figure that I hope is familiar to all of you. This is the challenge we all know is ahead of us. This is limiting the total amount of CO2 emissions and GHG emissions to net zero by 2050. There's a range of pathways and technologies that will enable this to happen. The one simple answer is that there is no one answer to doing this. There is no silver bullet, as it's often referred to. You need a range of technologies deployed at many different scales to enable this. And CCS is one of such technologies. So if you look at the curve here, which you see in front of you, typically what you see above zero, how to get, so what we refer to as CO2 reduction, that's where typically three technologies are highlighted also in the EU strategy. It's energy efficiency, it's renewables, which will take a very important and leading role in this, but it's also CCUS, carbon capture, utilization and storage, which will help us in targeting especially the hard to abate industries, hard to abate in terms of reducing CO2 from those industries. CCS will play a key role in enabling that to go towards zero. But truth be told, there's still going to be some residual emissions which will be hard or almost impossible to remove from the current carbon lifestyle that we have on the planet today, which means that we'll need negative emissions as well. And that's also a very important role of CCS to play, because there's two ways of actually enabling negative emissions today. One way is natural way of doing that, typically forestry, planting trees, enabling that in the most efficient way developed by the planet to this time. But the second one is technological, and that's where CCUS comes in, typically also referred to as BECCS, biogenic emissions CCS, where you use biogenic origin waste and feed that into a CCUS process and store the carbon permanently, enabling negative emissions, which in total will help us reach net zero. So in terms of the relevance of CCS, it's important to remember both what happens above the zero line as well as below the zero line. And a reflection is, of course, that with the current effort that we're doing on a global scale, global emissions are still rising. And the worse we do today, the more or the greater the need we'll have for negative emissions tomorrow. So basically, if you summarize this curve, it's do our best and then remove the rest. That's the current driver that we see. But every time I talk about CCS, and if you look at the next slide here, there's a bit of a need for a history lesson, I would say. CCS is often referred to as something new, something innovative in terms of technology, something that came out into the market recently. And the whole concept of CCS is, of course, taking CO2 out from the air, typically from a flue gas in a more concentrated form, which you find in the industry, and then compressing it, potentially liquefying it, transporting it, and then permanently storing it. If you talk about CCUS, and then especially the U, you could, instead of storing it, use this CO2 as a feedstock into making new products, typically products that would not end up by removing or releasing that CO2 into the atmosphere in order to have a climate effect, which is positive. But CCS has been around for a while. It's actually been developed all the time time back to the 1970s. So when people talk about CCS as something new, something innovative, it is indeed innovative, but it's not new. As an example, here in Norway, where I'm currently based, CCS has been around since the mid-90s. And what many people maybe don't know is that the two operational CCS projects are currently based in Norway. And they've been in operation all the way since the early 1996 with the Sleipner platform, and secondly in the early 2000s with Snøhvit. So on the Norwegian continental shelf, to date, they stored more than 25 million tons of CO2 safely underground. And the reason why you haven't heard about it, if you haven't, it's that because it's basically done in a safe, efficient way in terms of storing that permanently. And there's been no news around it basically because it goes so well. But this is basically the idea going forward, to target hard to abate emissions from industries and storing that in suited saline aquifers or depleted oil and gas fields for permanent storage, similar to what has already been done from the early 90s here in Norway. But this is, of course, also happened across other regions, both in the US and also partly in the Emirates, looked at in the past. If we look at the next slide then, so it's been around for a while, but as you see, the hockey stick approach is typically what is to come going forward. And then it's talk about the global status of the CCUS market and the momentum that we're currently seeing in that. CCUS in recent time has had its kind of moment in the sun. And you see that on the graph on the left side, graph number 1. From 2008 to 2012, CCUS also was seen as one of the key solutions, but with a slightly different touch to it. It was then typically targeted towards power industry, lots of coal in terms of decarbonizing coal, and it was also partly linked to EOR to a greater extent. Then the financial crisis, as well as lots of funding being pulled out of the projects, meant that you see the decline in the projects that after 2012 and to where we are today. And now what's different with the CCUS market today, which kind of has enabled this enormous growth that you see in terms of announced and planned projects in development. Number one, Paris is, of course, a very important driver. But secondly, and almost equally important for CCUS, is that CCUS is now not directed only to the power industry, and I would say not specifically to power at all. It's more towards hard-to-abate industries, as well as hydrogen, in terms of enabling this energy transition of hard-to-abate industry jobs, and to keep those through that transition, because we will still need steel, we'll still need cement, we'll still need these industrial processes and process emissions where CO2 is coming from after the energy transition as well. And that's one of the reasons why key strategies such as in the EU now realize that CCUS will be a key building block in actually enabling this energy transition to happen, by actually having the building blocks enable that will be necessary to do it. Again, referring to the steel to build windmills, the cement, etc., etc. So that's also why you see the incline here in number of projects going forward. I started working with CCS back in 2018, and then the Northern Lights project as part of Shell. Back then, very few talked about CCS, but we started hearing more and more, especially in the 2020s or early 2020. And then 2021 has just been a record year, and it continues to grow similarly now in 2022. So number of announced projects is huge. And the growth you see here is basically what will hopefully be realized going up to 2030. But if you look at slide number 2, you see the dark green bars on the right, referring to the IEA's net zero emission by 2050 scenarios. They state that in order to get beneath the 1.5 degree, you would need 1,670 million tons of operational CCUS projects on a global scale by 2030. If you compare that with the currently announced projects, which will be developed in the 2020s up to 2030, we're about at 1/10 of that. So even though we have such a huge growth in planned and announced CCUS projects over the last year and year and a half, 2 years, we still need that continuous growth every year if we are to reach that goal in terms of net zero emissions projected by the net zero by the IEA. If I could please go back to the previous and the slide I was at. 2 slides down, please. There we go. Okay. No, the previous one. Sorry, there we go. Stay on that slide. Thank you. And slide number the graph number 3 here is then highlighting how this looks for the EU. Again, there's only 2 operational CCUS projects in Europe at the time. That's 2 in Norway, but it's huge momentum around this, both in the Netherlands, UK, Belgium, Denmark, Sweden, Norway. Lots of things happening. France is very much moving along with this, and now there's also projects popping up in various regions across Europe, not to say, and also in the Mediterranean, things are moving for certainly. We are also, Germany as a market is also potentially looking into this from a blue hydrogen perspective. What's happening now in Wilhelmshaven in terms of the LNG import, also linked to a potential CO2 export terminal, is interesting to follow. So Germany as a potential CCUS market, also because of the high footprint of industrial processes, is also interesting to follow going forward. If we then look at kind of views on the market in the next slide, you see kind of where are those clusters actually developing. And again, it's 2 key markets that you should follow if you're interested to learn more about CCUS. It's Northwest Europe and it's North America, which is also the 2 key markets. There are lots of emerging opportunities also in Australia and partly around Indonesia, Malaysia. And talking about CO2 emissions, you can't forget China in that respect. They are doing lots of interesting pilot projects there as well. But the major momentum is happening around Northwest Europe as well as the United States. So if we then take a closer look to Europe, which of course is close to all of us in the next slide, there's always a question on kind of, okay, so these are the ambitions set by the IEA, but what's the total addressable market if you look to carbon capture and storage? Well, it's actually a question of where do you find opportunities to do something with that carbon, and that means basically storing it, because many industries would of course like to use this U that we talk about in CCUS, using the CO2 as a feedstock in order to create new products utilization. Truth be told, there's only going to be a smaller portion of that huge volume of CO2 that we need to abate, which can then actually go into building new products, which means that storage and availability of that storage is key in order to develop CCUS projects. You see here in terms of the heat map, where typically the largest clusters of CO2 emissions are currently located in Europe. If you look at kind of key industries for Aker Carbon Capture as an example, of these about 2,600 emission points, which are all eligible for CCS, about 700 of these are within key industries, and that's meaning cement, waste to energy, hydrogen, gas to power, and also increasingly biomass in terms of the negative emissions that I talked about. Many of these then need to be located close to a storage. That means typically around the North Sea, so Northwest Europe. But in addition, you could also then have access to a harbour, because the way projects are now developed, shipping is also a transport route for CCUS. It's worth talking about the value chain for CCUS when we talk about this. So in the next slide, you see a bit of the complexity when we talk about CCUS developments. Typically, if you read reports, you hear that this is the cost of capture, this is the cost of transport, and this is the cost of storage. Actually, this picture, and depending on the concept that you're looking at, is definitely not as black and white as that, as depending on the final destination of that CO2, the process, of course, leading up to that will be different. So if you see here, the CO2 will need to be captured in some way. And then depending on what you actually plan to do with that CO2, if it's utilization, and you see examples of that, for example, in our Twins project in the Netherlands, we are capturing CO2 from a waste to energy plant, and then the CO2 is prepared for transport with a truck, and then delivered to greenhouses in the near region to be used as a feedstock to enhance the growth of the plants in those greenhouses. But on the other hand, if you would like to transport that CO2 by ship or pipeline, you would typically need to either compress or liquefy it, put it on the ship or into the pipeline, transport it the given distance, offload it into then the injection site, and then permanently store it. So depending on what kind of value chain you are developing, these components and the individual cost of them will be different. So again, back to what's driving this value chain to happen in the various regions. And again, storage is key. If you then go to the next slide, as I mentioned, I previously, just in this example, how important storage is. I previously worked in the Northern Lights project, and a bit of history on how CCS storage has developed. Over the past, it's been typically one large emission point, and in close proximity, it's been a storage, and then a pipeline in between those two. So one emission point, one storage, which means that only those emission points with storage in close proximity were able to develop CCS. Now we see that this one-to-one dependency is actually broken down with introducing flexibility in the transport chain by using ships. And this is something new. And as an example, I had the pleasure of talking to a capture expert called Marco Mazzotti, the HS Zurich. And when he saw the Northern Lights concept for the first time, he called it a Copernican twist to the world of CCS. And what he meant by that is basically when you enable more capture projects to access a joint storage infrastructure, that means that CCS as an industry can take off, because best fit storage is key to develop CCS projects in the wider concept. So best fit for storage is indeed North America, Northern Europe, and then China, as well as Australia, is definitely also on the move here, but it's also where you see the typically bigger regions developing around CCUS. If we again take a closer look at Europe, in the next slide, please, you'll see here some of the huge momentum that which we are currently experiencing. If we looked at this list only, one and a half year ago, it would be 1/3, even 1/4 of this. So the number of projects being developed for storage in Europe is certainly increasing, and it's continuously growing. Actually, last week there was another license being announced, which should be added to this list. So it's continuously growing. That's great to see, because this will trigger decarbonisation of industry across the whole European continent. And then, of course, the remaining question is, so is the price? And if you look into the next slide, that's also a key aspect of CCUS. What does this cost? And this is currently, to some extent, in some markets, some industries, CCS is referred to as expensive. And again, this is coming back to the point that CCS is very much dependent on which industry you would like to capture from. There are examples of, for example, with high concentration CO2 streams in North America, typically around ethanol, where you have capture, transport, and storage costs all the way down to $30 per ton. So very low cost as such. Here in Europe, less ethanol as such, more typically towards lower concentration CO2, therefore also a higher cost. And also we have offshore storage, And offshore storage is typically more expensive than onshore storage. In the US, cost is higher. So here in the European market, you typically are closing up to that breaking point between an effective carbon price, the EU ETS, and the cost of CCS. And we'll need to continue to see a drop in that cost of CCS and potentially also a further increase in the effective carbon price ETS in order for the CCUS market to turn commercially throughout the 2020s. To the right here, you see Carbon Pulse from April 2022, basically a forecast or a joint forecast from all the predictors here going forward. And you see how can we expect the EU ETS price potentially to move going forward. It's had an incredible run over the last 1.5, 2 years, as you see in the black line here. How this will move forward, of course, everyone are curious to see. But I think definitely the drive to decarbonize and CCS as a tool that is not to be questioned when you see this curve. So then a bit about Aker Carbon Capture and how we fit into this picture. If we go to the next slide. So our mission, we're a pure play carbon capture company. And by saying that, I'm saying we're a separate company set up only to enable carbon capture for hard-to-abate industries and enable them to remove CO2. As a company, we're closing up to 2 years. So we're a startup, a scale-up, all those buzzwords, which basically means that we are moving as quickly as we can to enable this decarbonisation to happen. But we take with us a Aker heritage. So we are developed within the Aker family. We have our license and patent, which comes from the Aker solution, which has been developed all the way back to when we were part of developing the Sleipner platform. So our technology itself has been developed over more than 2 decades, but spun out in a separate company to enable that momentum, that flexibility, and that growth, which is needed in the CCUS industry. In the next slide, then it's all about our ambition. This is our North Star. This is what we're leading after. It's our 10 in 25. So our goal is to secure 10 million tons per annum on contract with CO2 capture by 2025. If you then go back to the numbers I showed you in the previous slides, you maybe remember that the projections for CCUS capture in Europe alone was 35 in 2030. So I would say 10 in 25 is certainly ambitious, both in terms of the scale, but even more importantly in terms of the timing. And that's important to underline. We want to move fast. We want to be a moving enabler, which helps this industry and upscaling to happen 1, 2, and even 3 years earlier than it intentionally was projected to happen. So we want CCUS to scale in order for this to basically help us all. So Aker Carbon Capture in brief, in the next slide, who are we and what do we supply? Again, a pure play carbon capture company, but what's special about us? One thing that we like to highlight is our HSC friendly solvent. So our technology is something called post-combustion amine capture, which basically means that we connect ourselves after the combustion process, and we use a liquid solvent called amines in order to capture the CO2 from the flue gas. We developed this amine over a project called Solvit, which at the time was actually the biggest R&D project in Europe. This started in 2008 and ran all the way to 2016, testing more than 100 different solvents in that program to basically come up with that chemical recipe, which you see in the picture there. And especially the HSC profile of that is especially important when you talk about amines and CCS to scale, because the emissions to air is one of the key drivers to actually doing this in a safe way. And that's our speciality as a company. Of course, you also need to showcase that you're able to build and demonstrate this technology to scale. And we're proud to say that we have validated and certified our technology with more than 50,000 operating hours. In terms of our history, if you go to the next slide, please. As I mentioned, we've been around for a while. We've been around since 1996 with the Slightly platform, the Solvit program, which I mentioned here from 2008 to 2016, but then also some follow-up projects there going forward, means that we're now in the position to accelerate the commercialization and project development of our technology, and we want to help the CCUS project and CCUS industry grow going forward. I'm not going to go into technical details and kind of the process of this, but if we go into the next slide, I'll show you briefly how the technology works. This is basically all the different industries which we've tested at. So you see here the range of those industries. I talked briefly about that when we looked at the European map. So natural gas, coal is also one that we tested out specifically back to the previous period, which I talked about with CCUS. Cement, waste to energy, hydrogen, and also now increasingly we see also a need to go into process industries, as they will also need to be present after the energy transition. Next slide, please. So how does this work? So again, this is post-combustion process where the CO2 is led into the absorber, and it's interacted towards the amine, which then is led in opposite phases. So smoke, flue gas going up, amine coming down, and the amine then absorbs the CO2. Then into the desorption, through heat, the CO2 is released from the absorber, and then you can take this further into liquefaction or compressing for whatever use you are to use the CO2 for, if that is either storage or utilization in that case. Key markets and industries, and this is not maybe coming as a surprise for you in the next slide, but our key market is exactly where we see this developing the most, and it's Northwest Europe, Scandinavia, Norway, Sweden, Denmark, Benelux, and the UK. But it's safe to say that we are definitely closely following what's happening in North America, as well as other countries in Europe as well. And we are very fast moving in this. We just 2 weeks ago, we set up our first office in Sweden. Just a half year before that, we set up our office in Denmark. So we are basically both trying to help enable the momentum and also follow the momentum and grow the momentum in those key markets as we move through. And again, prioritize industries, cement, bio or waste to energy, gas to power, and blue hydrogen, which are all key industries to take us through the energy transition. In terms of specific offerings, I'm just going to show you here what we have in terms of equipment in the next slide. So we typically have 3 key offerings around this one technology. It's the Just Catch, which is our modularized and standardized offering of the amine post-combustion capture. So this is typically delivered in 40 or 100,000 ton modules, which can then be fitted on in series or parallel to a given industrial site. Then it's the Big Catch, same technology, but this is tailorized development. So typically, as you know, if you know EPC projects, so going through all the phases from feasibility, concept, FEED, and then construction execution. So these are starting from typically around 400,000 tons per annum in terms of emissions, and we're scaling this up into the 1 million ton scale. So as an example, we are now building at the Norcem Heidelberg site in Brevik, in Norway. We are building the world's first CO2 commercial scale plant right there, and that's for 400,000 tons. But in addition, we're also part of the FEED and the Net Zero Teesside in the UK, and that's on a 1 million ton scale. So you see a bit of the difference and the span there. The Just Catch offshore, still same technology, but this is then fitted onto typically FPSOs to decarbonize the power system on those to enable that part of the value chain to be decarbonized in terms of the production of oil and gas offshore. If we go into specific projects, and I'm going to show you 2 specific projects here in the next slide. So first, you see the Norcem cement plant, which I talked about in Breivik, Norway. So here, 400,000 tons of CO2 will be captured every year and it will be liquefied, sent onto a boat coming from Northern Lights, the transport and storage project developed by Equinor, Shell, and Total, and then sent to the west coast of Norway into a pipeline, permanent storage. So this is a CCS project using our Big Catch technology and Big Catch offering as such. If we then go to the next slide, you see a different example, which we actually last week just started building in Twente at Hengelo in the Netherlands. So this is our Just Catch offering, the 100,000 tons module at the waste-to-energy plant at Twente, where we are capturing CO2 and feeding that onto trucks, which is then going out to the local greenhouses, as mentioned previously as well. This is a CCU project, carbon capture and utilization. So already we have two projects which are actually exemplifying the two varieties of the CCUS value chain and with the two various offerings that we have. In the next slide, I just want to give you a brief overview. There's high operational activity. It's safe to say we're involved with the two projects which we're currently building. We're involved in feeds, we're involved in early studies, and this is just a snapshot of some of the ones we are involved with across different regions. So it's safe to say we are busy these days. However, in the next slide, I also wanted to show you a bit on how we are moving the market. So we are a pure play carbon capture company, which means we are focused typically on the left side of the value chain, CO2 capture, liquefaction, compression, and potentially intermediate storage before transport takes this into potentially then permanent storage or utilization. But we see that in terms of the complexity across this chain, a lot of the emitters actually need to simplify this in order to enable their projects to go forward. So in the next slide, you'll see how we chose to solve this. Carbon capture as a service, carbon capture made easy, is our solution in terms of enabling a one-stop shop for emitters to go to one party, that being Aker Carbon Capture, which will enable the full chain from the financing, the capture, the transport, and the storage under a pay-per-ton model. So instead of actually having to handle the full complexity, talking to different suppliers, different technology providers across that chain, we are acting then as a one-stop shop and enabling this to happen. However, we continue to be a pure play carbon capture company, but we are enabling this through strategic partnerships. And in the next slide, you'll see some of the strategic partnerships which we are proud to have with some of the key transport and storage projects across Europe. So basically, we are working closely with the companies and projects that you see here on the screen in order to enable the most cost-efficient projects across Europe in terms of enabling those point-to-point projects to actually develop. And again, this is very dependent on geographies, it's dependent on scale, it's dependent on industries. So you need a special fit for each of them. And we aim to act as the one-stop shop for emitters to enable those value chains to happen together with our partners. And then the key question is, of course, is always, so what does this cost? And the indicative levelized cost of this is shown actually in the next slide. I'm just going to show this, and this is from our Q4 presentation. Again, this is for the carbon capture as a service, as a reference for all of you. So this is not the Big Catch project. This is for the Just Catch 100 module, which I showed. And that's where the carbon capture as a service is currently focused around. That's the standardized, that's a modularized version of our offering, where we are also able to offer this as a service. You see here currently the cost breakdown, and I'm just going to highlight that where we see the biggest uncertainty currently is still within the transport and storage aspect. So we are working closely in that market to see how we can enable, especially now in the early days of that upscaling market, of that hockey stick, we are working closely with them to enable this to happen. But I also want to touch briefly on a separate part of the commercial chain of CCUS, and I'm trying here to cover the full picture in short time. But if we go to the next slide, and this is now a familiar picture to you, We've talked a lot about what happens above zero to this point. We talked about the hard-to-abate industries. We talked about cement. We talked about waste-to-energy, steel, all those who need to be reduced in order to get down to zero. It's important to underline that what's happening now in negative emissions is also extremely interesting when it comes to CCUS. So in the next slide, again, just to underline this point, there's a big difference of the origin of CCS. Is it fossil CO2 or is it biogenic CO2? Fossil will be driven largely by the ETS. Biogenic, on the other hand, will be largely driven by the voluntary market as of now. The EU has said that it will come with updated framework into how the biogenic voluntary market will be playing into the regulated market of the ETS around year end this year. But for now, please be careful that these two are two different worlds in that respect for now. As an example of why this is exciting, let's look at Sweden here in the next slide. Just as an example, and why Sweden? Well, because Sweden, if you look to the left here, they have 98 facilities above 100,000 tons of CO2 emitted annually. They are if you look at the overall industry footprint, they are the country in Europe which have the biggest share of biogenic emissions, about 50%, as you look see to the picture to the right. And this means that actually Sweden right now is looking to potentially see negative emissions and carbon credits generated from negative emissions to potentially be a future export industry for Sweden. So if we see in the next slide, you'll see here a overview of corporate purchases of carbon removal credits from 2021. And it's still small volumes considerably. It's around 60 to 70,000 tons for over a year. And you see some of the key buyers here. But if you're following this market, you've also recently seen already in 2022 that initiatives such as Frontier with Meta and similar Shopify, Stripe again, have joined together in a 1 billion purchase guarantee up to 2030 to buy carbon removal credits in the market. And if you then look to the price at which these credits are traded at, we're seeing prices from $75 per ton, which is similar to the ETS currently as a comparison, but all the way up to 2045. Big range, emerging market, voluntary credits, but very exciting to follow. So when people ask what's going to finance CCS going forward, it will be a combination of ETS, carbon tax, both international in terms of ETS, as well as national, as you see emerging in Norway, Denmark, Netherlands, UK, for example. It will also be funding, governmental funding will be key. It will be a green premium on the products enabled, such as green cement, for example, if you can enable a green premium on actually having low carbon or zero carbon cement. And in addition, it will be carbon credits generated from carbon removals through biogenic emissions. And all this comes into play into creating that future CCS market. So with that, I hope this has intrigued you a bit and that you're curious to learn more. It's definitely a fast-moving, high-momentum market, and very glad that I got the opportunity to share this with you. And thank you, everyone. Next slide should be the finish and the Q&A. Thank you.
Okay, thank you very much. There are 4 minutes left, and we will see if there's any question in English for you. Yes?
Hi, Emil. Thank you for a wonderful presentation. I had a question on one of the slides where you showed that there is a break-even point between price of carbon and cost of CCS. Now, I was curious to know, capture cost is probably understandable, but the cost of storage, it seems to me like if it's permanent storage, then it's got to be permanent costs as well. So could you throw some light on how the costs of permanent storage will evolve and what do you think about it, how you think about it? Thank you.
Good question, and thank you. So in terms of cost of storage, there's again, various data points in terms of that. So if you look to the US, I think a good rule of thumb is we look at about $10 per ton for the storage part, and then you look in terms of transport, which is typically pipeline, somewhere from between $10 per ton to $25 per ton, depending on distance, and especially if you need boosting stations for that pipeline. Again, this is all onshore-based storage, so you don't, in terms of cost of material and cost drivers with respect to bringing this subsea, it's a different market. When you go into the subsea storage and doing this commercial, this is all projects developing today, and basically the only commercial project which it has taken FID is the Northern Lights project. And in the Northern Lights project, in terms of will the cost be static and be permanent at a certain level? I think this is, again, looking back to innovation and innovation across the value chain. So let me exemplify that by saying Northern Lights is ships. It's an intermediate storage, lots of tanks, pumping stations, and then it's a long pipeline, 110 kilometers, and then a permanent storage. It's a brilliant concept. It enables flexibility and joint storage. But then again, in future innovations of such a value chain, one could potentially look at taking away the intermediate storage point and make that into an offshore injection point, taking away the infrastructure on land and actually removing that long pipeline. That will lower the capex and therefore also lower the permanent cost of storage. So you have projects developing which are currently looking into this, haven't taken FID yet, but they are definitely in the making and they look to be operational around 2025, 2026. So that's when we know for sure how kind of the different costs of offshore storage in Northwest Europe will be, how the cost picture will look like at that point.
Okay. I think there's no more question. And Emil, thanks a lot for explaining us the CCUS market and what you do. We are just in time for the next topic. Once more, thank you and all the best for you.
Thank you. Take care.